We're going to look at problem solving with equations when we're using uniform motion. Now, with uniform motion, this is an object that moves at a constant rate and it's said to be in uniform motion. So basically it's a car moving down a highway or a car driving on the street as long as there's no stop signs and stoplights, or maybe just a boat on a lake. It keeps going, or if you're going for a walk and you don't stop, you're at a constant rate. So when we have these types of problems, we're going to use two things. The first thing we're going to use is formula distance equals rate times time. So it's d equals r times t. And we're also going to draw a table. Now the tables are very important. I know it sounds tedious, but these help you organize the actual problem and you can see better what you need to do to solve the problem. So for the first one, we're going to take a look at same direction, meaning when two objects are going to the same point. They both start at point A and they both go to point B. Now this says a train leaves the train station at 1 p.m. It travels at an average rate of 60 miles per hour. A high-speed train leaves the same station an hour later, traveling at an average speed of 96 miles per hour. The second train follows the same route as the first on a track parallel to the first. And how many hours will it take for the second train to catch up to the first train? Okay, so basically it's asking us the time portion of the distance equals rate times time equation. So we need to know, okay, the time of the first train we're going to say is x. The time of the second train is x minus 1 because it leaves an hour later. So once we've already established that, we're going to put up our table. When I'm doing in this table, I need a column that states to me, what each row means. I've got my rate column, my time column, and then my distance column. So, our first train was traveling at an average rate of 60 miles per hour. Okay, our second train was traveling at 96 miles per hour. Alright, now our time. We're going to set our time, which we don't know, is for the first train. We're going to say that's x. Okay? Then our second train, its time is an hour less than the first train's time. So it's going to be x minus 1. Alright, so distance. Remember, distance is your rate times your time. I know my rate's 60, and I'm setting my x for my time. So if I multiply these two together, I get 60x. Now, same thing for here. 96 times x minus 1 is going to be my distance. Granted, it's an expression, but still it's considered our distance. Alright, now that we know these two, since we're both going to be, the trains are leaving from the same spot and going to meet at the same spot, their distance is the same. They're going to be traveling the exact same distance. So, we can do with that is we can set these two expressions equal to each other because they're both starting at point A and going to point B. So if we put them equal to each other, then solve for x. So we got to distribute the 96. 96 times x is 96x. 96 times 1 is 96. And I have a minus because the minus here. And it still equals 60x. You subtract 96x from both sides. 60 minus 96x is negative 36. And you're left with the negative 96 over here. Then you're going to divide each side by negative 36. And you get x to be 2 2/3 hours. Or 2 hours and 40 minutes. Now this is how long the train 1 will actually travel until it meets up. But train 2 will actually travel an hour less than that. So that will be about an hour and 2/3 of an hour. Or you can say an hour and 40 minutes that train will travel. Alright, the next one we're going to look at is a round trip. Like when you go to the store and back. That whole trip is round trip. It's still the same distance from home to the store as it is from the store home. So, we've got Jill drives into the city to buy a software program at a computer store. Because of the traffic conditions, she only averages 15 miles per hour. On her drive home, she averages 35 miles per hour. If the total time traveled is 2 hours, how long does it take her to drive to the computer store? Okay, set up your table just like this. Going to the store, it says that I traveled at 15 miles per hour. So I put 15 for my rate. Now home, it says I did 35 miles an hour. I know my time, it says the total time is 2 hours. Now if the total time's 2 hours, let's say we'll put to the store because that's really what we want to look for. I'm going to set that as T. And if I want to know how long it took me to come home, I know the total is 2 hours. So coming home is going to be the 2 hours minus how much it took me to get there, so minus T. Then remember, distance is rate times time. So I do 15 times T, and that's 15T. Then I do 35 times 2 minus T. Notice my distance, again, is actually expressions versus an actual number. Alright, so since it is the same distance to the store as it is from the store, we're again going to set these two expressions equal to each other. So the 15T equals the 35 times 2 minus T. So I need to distribute my 35. 35 times 2 is 70. 35 times minus T is minus 35T. I'm going to add 35T to both sides. When you do 15T plus 35T, you get 50T. And you're left still over here with 70. Now I'm going to divide each side by 50. And I'm going to get my time to the store is going to be in 1.4 hours. Now, if it also asks you what was the time coming home, all you need to do is take your 2 hours and subtract your 1.4, and you'll notice that it only takes 0.6 hours to actually come home from the store. Alright, the last type of uniform motion is opposite direction. Like if we started at the same point, one person went north, one person went south. Those are opposite directions of each other. So we've got Jane and Mike leave their home traveling in opposite directions on a straight road. Mike drives 15 miles per hour faster than Jane. After 3 hours, they are 255 miles apart. Find Mike and Jane's rate. Now notice this is the first problem that has actually given us a distance in numbers, and that's right here. That's because from here, if we both start here, Mike goes this way, Jane goes this way, but from here to here is 255 miles total when you add the sum of both distances. So let's set up our table. Now Jane's rate, it doesn't give it to us, but Mike does drive 15 miles an hour faster. So we're going to do Jane as R, since Mike is R plus 15. He's 15 miles faster. Alright, time it tells us, which is this 3 hours right here. Okay, so distance, remember, equals distance, that, rate times time, not distance, rate times time. Alright, so R times 3 is 3R. We're going to do 3 times R plus 15. Alright, this time, now, it's a little different than the previous examples. Basically, from the start to where Jane is the distance 3R. And from the start to where Mike ends up, it's 3 times R plus 15. And this whole distance equals 255. So what you need to do to find the rates is you're going to add these two distances together, these two expressions together, and set it equal to the 255. So if I do 3R plus 3 times R plus 15 equals 255, I'm going to distribute this 3, so 3 times R is 3R. 3 times 15 is 45. I'm going to combine the 3R and 3R to get 6R plus 45 equals 255. Subtract 45 from both sides, and I get 6R equals 210, and divide each side by 6, and I get a rate of 35. Now this is just Jane's rate. Remember, Mike drives 15 miles per hour faster than Jane. So you've got to add 15 miles per hour to that to get Mike at 50 miles per hour. Alright. now to sum up basically what we have done in this lesson is we need to use, when we're using uniform motion problems, we need to use the formula distance equals rate times time. Remember, D equals R times T. Okay, then we had three different types of problems. We have same direction, that is when they catch up to each other. So they both start at point A and they both end at point B. When we do this, they're both going the same distance, the same total distance, so your distance equations will be equal to each other. Now, round trip is when you go there and back. Like when I start here from my house and I go to work, is the same distance as when I go from work home. So it's there and back. These, remember, distance is going to be the same, so your equations will be equal to each other, or your expressions will be equal. The only one that you add them to, you add the two together, equals the distance, is the opposite direction travel. That's when one goes right, one goes left, but we start at the same point, and we need to add each other's distances together to get out how far apart we are in the end. So the distance sum to the total distance traveled. These you add the distance equations and they sum to the total distance traveled. This is the only time you're going to add them together. Other than that, same direction and round trip, you set them equal to each other.